Now we'll go back to the conceptual level now. Because as a person, as a student, business student who has studied data analytics courses, right? If you just know how to use the software, it's not enough. For example, in this building, we have some high schoolers, right? What is the difference between those high schoolers and you? What is the difference? Does how to operate the software make the difference? No, right? If I give the high schoolers a 1-hour lecture to teach them how to use the software, they can operate Excel as well. Maybe some of them will operate better than you guys. Maybe, right? The major difference that makes the difference, the major difference between you who have studied business analytics courses and the high schoolers is that you should understand the concepts that build the linear regression model. That's why from today, we'll go way back to the conceptual level now. At this moment, we have seen many applications, linear programming, linear regression, right? From today, we'll go back to the conceptual level. Let's go back to chapter 2. Chapter 2 is about data preparation. As we discussed in the first lecture, business analytics is a subject dealing with data collection, data preparation, data analysis. So from today, we'll talk about the first step, data collection and the data preparation. In this chapter, the main concept is how you collect data and save data in an efficient way in the database system. We'll talk about the primary key, foreign key concept. Let's take a look at an example. Okay, so suppose now we are working for a technology company, like an e-commerce website, right? We are charged of a task. We are asked to design a database system to record the transaction information every time when a customer places an order on the e-commerce website. We have an intern, right? Just a graduate, freshly from college. And he designed a database like this one. He said, okay, boss, you said I need to record everything once a customer places an order on the website, right? So let me save everything into one table. This customer's name, right? Address, obviously. Address, email, phone number, right? What's this customer ordered? iPhone, right? Price per product. I have 2 questions. First, is the intern correct? Second, is this good? Is this design correct? If you want people to collect data like this, is this correct or not?
I think it's correct.
It's correct, right? He got the job done. He recorded everything. He didn't miss a thing, right? So it's correct. Second, is this efficient? No, why not?
Lot of information.
Can you speak louder? I cannot hear from here. Who said?
I said lot of information not required is much for it.
Can you further discuss your idea?
Like
I think you are on the right track.
like address, those things are not necessary for us. We just need the information if the iPhone
Exactly.
was ordered
Exactly.
and what's the amount.
Yeah,
Those
very
things.
good answer. You see, we don't have to, we already know the customer's name and address. We don't have to repeat recording the known information over and over again, right? If we do, our software, our computer space will explode. We have to buy lots of memories to store data that are redundant. And you should know that the memory, the computer memory price right now, it's not cheap, very expensive, right? Do you know which stock performed the best last year? Have you heard of a company called Western Digital? Have you heard of a company called Seagate? What about Micron? Those are the companies with best stock performance last year. Why? Because the price for memory skyrocketed, very expensive, right? So if we keep recording the known information, we have to buy lots of expensive hardware to save some information that are redundant. That is redundant. It's not necessary, right? So we can improve this design. The Intel gets the job done, but it's not in an efficient way. We can change up. This is data redundancy, right? Let's say the same customer places the second order. His name, address, phone number are known. According to the Intern's design, we have to keep recording the known information. That's not efficient. That's why we want to change the database design into this way. We split the entire data table into particular tables. For example, we create a customer table. We only record the customer information into the customer's table. Also, we give each customer a unique ID. Can you see that? Unique ID here, over here, right? We call this column customer ID. So in the future, when a customer places an order on our website, we only need to record customer ID, right? So we don't have to keep recording the customer name, address, phone number, email over and over again. This customer ID number can save a lot of computer storage space. This is one way to improve it. Also, when a customer places an order, in addition to order date, what the customer ordered, we also give each order, each transaction, an order ID. Why do we want to do this?
One customer can order multiple.
It can improve the searching performance. For example, what if the customer had some issue about the product that they ordered? They contact the customer service, right? If you don't have this unique order ID, the customer representative need to search by the customer's name, date of order, right? What product that they ordered. It will be very difficult for your representative to search this transaction. But with order ID, the customer only need to tell you the order ID. You can search, find out this transaction. So we give each transaction an ID as well. In the order table, you can see we have both order ID and the customer ID, right? Can you see? We have two IDs. Order ID in the front and the customer ID at the end. They have different purposes, obviously. What is the difference between the two columns? Order ID is to identify a unique record Within which table? Orders table, exactly. Right? We call order ID a primary key. Primary key. So in the future, when you design a database, you could have a lot of tables, right? For each table, you need to have at least one primary key. The keyword here is at least one primary key. You could have 2, 3, doesn't matter. But remember, no matter what, the purpose of a primary key is to identify one unique row in the data table within the table you are looking for. For example, order ID. Order ID in the orders table can only locate one unique transaction, which means if a customer tells you an order ID number, you can only locate how many rows of records in the orders table? Only one, exactly. If you treat order ID as a primary key, it cannot locate 2 or more rows if you only have one unique order ID. But we have a customer ID in the orders table, right? If you type in one customer ID in the orders table, do we necessarily have just one record? No. Why not? Because one customer can place multiple transactions, multiple orders. But if we type in customer ID in another table, customer table, how many customers can we locate if we are given one unique customer ID? One, yes. So as you can see, in the orders table, we have a customer ID column. They cannot locate unique record in orders table, but they can locate unique record in another table, customers table. For this type of column, we call it foreign key. Foreign key. It's a primary key that locates unique record in another table. Right? If we change the design from this, a very, very messy structure, to this, we call this entity relationship database. Entity relationship database. Very important concept. Obviously, for some business analytics students, you will study more about the entity relationship database design in BUSA 526 class. Right? You need to further develop a database to make data retrieval more efficient. Right? But for this class, since we have a non-business analytics student, as long as you understand how you split one data table into entity relationship database, that will be good enough. Of course, if you are an MBA student, once you understand this concept, when you direct your business analyst to design database in the future, you want them to design in this way. Right? We don't have visible lines to connect tables, but we have this invisible logic between tables. So if you can design a database like this, you will significantly improve the data searching, data management efficiency. Very important concept. Are we all good about this? As you can see, we can keep expanding the entity relationship design concept. For each product, we give a ID number, right? We record the product name, category, weight, and so on. Everything related to product will be recorded in product table. Everything related to customers will be recorded to customers table. So we call each table entity. That will be a table with themes. Customer table is only related to, only records customer information. Product table only records product information. And eventually, you see, we have an order detail, right? If you have a very good design, eventually, when the customer places an order, eventually the order detail only records numerical values. That will be perfect. Why? Because from the computer design perspective, numbers take much less space, computer space, in a computer system. And numbers are easier to search, to analyze, to manage. So if you have a good design, eventually you will have an order detail table like this. You see, everything in order details, everything in this table is numbers. That will be perfect. This is called normalization. Of course, you don't need to worry about normalization for this course, but at least you need to understand we need to design a database in this way to improve data management, data collection efficiency. The rest of the PowerPoints talk about the concept I just mentioned. You can take a look at the PowerPoint at home, right? This is an example. You can design a database in this way, right? You see some notations here. 1 semicolon M that represents one to many relationship. For example, one customer can place multiple orders, right? You don't need to worry about those notation, but you do need to understand what entity relationship database design is for this course. The next important concept I want to talk about is how to process missing values. Yes. How to process missing values? Once you are given a data set, you need to look at the data set, right? You need to know something related to the data set, like the mean value, standard deviation, which we will be talking about very soon. Another thing is about missing values. Sometimes you will be given some data set with lots of mess, like missing cells. You don't have certain values in certain cells, right? So how can you process those missing cells? Several strategies. For example, you can calculate the mean value of the column of the entire data set, and then use the mean value to fill out those missing cells. That's okay. That's okay, right? Or what else? How can you fill out those missing cells?
Take it out.
Just to remove the records. Yes. That's another strategy. Yes. Very good. What else? Probably you need to fill out some values with your experience, right? According to your understanding about the industry, according to your prior knowledge, right? For example, let's say we have a customer income. We don't have that value. We miss one value in one cell. right? Then we can estimate according to our knowledge about the general population. We know that the average income of a customer, annual income, is about $70,000 every year. So we can use our prior knowledge to fill out those cells. That's possible. Several different strategies. As long as you can explain your justification. That's very important. I want to talk about the missing values because many of my previous students told me that when they go on an interview, they ask about this. So I want to share this information with everyone. How to process missing values. Right? We talk about using mean value of the data set. We talk about removing the column, removing the rows, missing rows. We talk about the prior knowledge. They are all good strategies. Right? This is how we prepare a data set to make it complete, accurate. Of course, accuracy here is to be as accurate as possible. The nice thing about the business analytics is we can use some estimation to fill out those missing values. Right? We are different from medical research. Medical, you cannot use estimation. You can't. You just need to use experiment data, the data that you received from the reality. You cannot use estimation. But business analytics is a little flexible. And the nice thing about the business data is sometimes we have actual data, like financial data. If you miss some value, you can always look back to retrieve the stock price and so on, to retrieve that, to fill out the missing value. Several different strategies. Okay, this is chapter 2. Next, I want to talk about chapter 3. Summary measures. So this chapter tells everybody how to look at the data properties once you are given a new data set. When we talk about this, we look at two important properties, centrality and dispersion. Centrality and dispersion. Simply speaking, centrality is looking at the mean value of your data set. Of course, we have several different types of mean values, right? For example, we have average. Average is equivalent to mean value. We can also look at centrality according to median. According to mode. They represent different things. Mean value, basically, you can look at this equation. You can use this equation. This is a mathematical equation showing you how to calculate centrality and dispersion. I'm not going to talk about each symbol of an equation, right? I think as long as you have a basic mathematical knowledge, everybody can understand what this means. This is how you calculate the mean value. Of course, we just talk about statistics. Every time when we talk about statistics, we need to look at the population factor and the sample factor. Sometimes the mathematical equation is different for population calculation and sample calculation. Most of the time, they are the same. For example, when you calculate the population mean and the sample mean, we use the same way. Basically, we need to calculate the average value of the population and the sample. Any question about this? Then we can calculate median. Median is basically it's an average value, but it is another way of calculate median value. First, we need to rank the data set from the smallest to the largest. Or you rank the data set from the largest to the smallest. It doesn't matter. Doesn't matter. Then you want to look at the value that is located in the middle. Located in the middle. That will be the median value. Median value. Right? If you have an odd number of data set, then the one in the middle will be the median. Right? But if you have even number of data set, then the two in the middle will be the median value. You need to calculate the average value of the two in the middle if you have an even number of data sets. All good? Then we have mode. Mode is another way to measure the centrality. Mode is the value that appeared in the data set most frequently. That is mode. Right? Sometimes you have just one value that appeared in the data set most frequently. Sometimes you have two, three, right? If you have two most frequently appeared value in the data set, then your data set is called a bimodal model. Multi-module model. If you only have one value that appeared in the data set most frequently, that's called a union module. This is centrality, how you measure centrality. So I get a question before, why can't we just use average value to measure the centrality of the data set? Because sometimes if you just use average value, it's not accurate. For example, the US people's annual income level, annual income number. We can calculate the mean, right? We ask each US person's annual income and then add them up divided by the population, the number of population. Obviously, that's not accurate, right? Because some people will get lots of annual income, like those billionaire, millionaire, they have lots of income. They will drag the centrality of the data set toward higher income. So that's why we cannot just rely on the mean value. We have to look at median and mode. Most likely we'll use median in practice because you rank the data set, right? It's more accurate. That means if you have a median value, then 50% of the data set is more than that median value. Another 50% is less than the median value. That is the real mean. This is how you measure centrality. So the next topic is dispersion. This variable measures how the other data sets vary around the central point. whatever you use, mean, median, and mode, you identify the central point of the data set, right? Another factor you need to consider is how the data set overall changes, varies around the central point. We use dispersion factors to measure that. Several ways. Standard deviation is the most frequently used one, right? This chart shows everyone how you can implement the Excel functions to calculate different factors about the data set. I will not go over this. You can try it out at home. Very intuitive to understand, right? For example, if you want to calculate the mean value, you use average. If you want to find the largest value of a data set, you use max. Smallest, you use mean, and so on, right? I want you to try them at home. I will not go over these functions. Very easy to understand, right? This shows you some example. Now we talk about dispersion. How the data set changes, varies around the central point. We can use something called the interquartile range, IQR. The way to calculate this range is you can rank the data. Ranking the data is very important. If you want to calculate the median, quartile value, always ranking the data first. So if you want to calculate IQR, first you need to rank the data from the smallest to the largest, or the other way around, from the largest to the smallest, depending on what you want to do. Most likely, we will rank from the largest to the smallest, most likely. Not always the case, but most likely. So for the rest of the discussion, we always rank from the largest to the smallest, right? And then we can find the median value, right? That will be the value in the middle. That's the median. Another name of that value is the value at the 50% percentile. So when we calculate IQR, it's a range. First, we need to rank the data from the largest to the smallest. You can do another way around, but as I said, we just for this class, we always rank the data from the largest to the smallest, right? And then we are able to find the mean, the median. Median, another name of the median value is the value at the 50th percentile. Right? If you find the median value, you know that more than 50% of the data set is greater than the median value. Another 50% of the data set is less than the median value. That's why we call the median, another name is the value at the 50th percentile. Have you taken some standard exam like GRE, GMAT? If you have, then you will be given your result, your performance according to percentile. Let's say you get 70, your score is at the 75th percentile. That means you perform better. Let's say you have 100 exam takers, you are better than 75 people in the exam. your score is at the 75th percentile. It's better than the other 75 people. Right? And of course, we can find the largest and the smallest, right? The mean value and the maximum value. Max and the mean. And then we can find the quartile values. Like the first quartile, second, third, and fourth. Can we? Yes, we can, right? Quartile represents 25%. So first quartile equals to the value of the 25th percentile. Do you all agree? First quartile. First quartile equals to 95th percentile. Can anyone tell me what's second quartile equivalent to? Median, right? That's a median, 50%. Very good. 50th percentile, which is median. Third quartile, 75th percentile, exactly. Very good. And fourth quartile, maximum value, right? Maximum value, 100%. 100%. This is their relationship. And when you calculate RQR, this range, you want to use the value at the third quartile minus the value at the first quartile. This is the equation. The interquartile range equals to the value at the third quartile minus the value at the first quartile. It's still a range, 50% of your data set, right? But this is the equation when you calculate it. The reason we want to know this range is that we need to look at outliers in the future. Later in this lecture, I will talk about outliers. That's why we need to know how to calculate IQR. Okay, very good. This is one way to measure dispersion. Another way is something called the mean absolute difference, MED value. So basically, you want to use each value in the data set minus the mean of that data set. Calculate the absolute value of the difference, add the absolute values together, divided by the number of data set, the number of data in the set. This is the equation. I want you to get in touch with this equation. You don't have to necessarily remember these equations because you can use software to calculate those values, right? But I want you to know where you can refer to when you are asked about the conceptual models. Why? we calculate how we calculate this MET value, how we calculate this IQR value. You need to know where you need to look for the equation. This is the second way to calculate dispersion. The third one is standard deviation, which is very important. Remember these two equations. Standard deviation. Standard deviation, I think, is the most frequently used factor to measure dispersion of your data set. So the way to calculate the standard deviation is you use each data value minus the mean. And then you calculate the squared value of this difference. Add up all the squared value, then divided by the number of data set, the number of data in the set. Remember that. These are just some mathematical equations, so there's nothing to say about them, right? No matter what, you have to follow these mathematical equations to calculate each factor. Nothing to see, just learn them by heart. One point you need to pay attention to is, here we talk about two ways of calculations. If you calculate the population standard deviation, the denominator should be n, the number of data in the set, in the population set. If you calculate the sample standard deviation, the denominator should be n minus 1, the number of data in the sample set minus 1. That's a major difference. So before you calculate standard deviation, you need to figure out, is this standard deviation is for the population or for the sample? If for the population, divided by n. If for the sample, n minus 1. This is the third way of calculate dispersion of the data set. Remember, no matter which function you use, right? All of these dispersion factors are showing you how the data set changes around the mean. That's an ultimate goal. Just a different way of calculate. Here, this PowerPoint shows you some Excel functions, right? If you use mean, you can calculate the smallest value of the data set, max, percentile, right? I don't think Excel has a quartile. But as long as you understand the relationship between percentile and quartile, you can calculate quartile value as well, right? Because the first quartile equals to the value of the 25th percentile, and so on. So you can still use quartile, you can still use percentile function to calculate quartile values. Standard deviation, right? Variance, right? Variance is just this value. These are the variance value. If you want to calculate standard deviation, you basically get the square root of sigma squared and s squared. That will be the standard deviation. How can we use the centrality and the dispersion for business analytics? Here is an example. If you study finance, you will get in touch with a concept called the Sharpe ratio. Sharpe ratio basically measures how much additional profit you can get if you take one additional unit of risk. And this is the equation how to calculate Sharpe ratio. Suppose we have a risk-free rate Usually in practice, that will be something like the treasury rate. You know treasury? Treasury is a bond issued by the US government. Because US government is very stable, so the bond from the US government is considered stable. It's considered like risk-free. This is just a convention. I see some people, some classmates smiling, right? When I say the US government is the most stable unit. But this is just a convention for finance people. You will not be asking about this equation. I just want to show you an example how you use centrality and dispersion in reality. But if you study finance, if you want to calculate which stock is worth investing, then Sharpe ratio is a very important factor to consider. As I said, it shows you how much more additional profit you can get if you take additional unit of risk. And this is a way to calculate it. You use the return of the stock of your investigation minus the risk-free rate. Usually that will be like a 10-year US government bond rate, treasury rate, right? Because you are calculating the additional profit you can get. That's why you need to subtract the risk-free rate. Risk will be represented by the standard deviation of the return. That's why you need to divide the difference between return by the standard deviation. This is how you calculate Sharpe ratio. And this shows you an example. You don't need to worry about Sharpe ratio for this course because this is not a finance course. But you can see how we use centrality and dispersion in reality. Most likely, in practice, once you visualize the data set with centrality and dispersion, you will draw a bell shape like this one. On the top, mode, mean, median are all equal. For this type of data set, we call them normal distribution. Remember the very top one, right? You can take a look at the bottom two. If you don't remember the bottom two, that's fine for this course, but remember the top one. If you have a symmetric bell shape, this data set is called a normally distributed. What is the key feature of a normal distribution data set? Can you tell me? Mean, median, and mode are all equal. Yes. You see, under the bell shape, we have a vertical line. What does this line represent? The frequency of that value. How many times this value appear in the data set?
One.
Not necessarily one. But you can know that if you have a normal distribution, the mean value, median value, and mode value are all equal, right? The value in the middle appeared the most frequently in the data set. Why? Because that vertical line corresponding to that value is the tallest under the bell shape. Right? Remember that. The vertical line represents the frequency of that value. So, what does this axis represents? x-axis, x-axis. We have a plane, right? We have a y-axis, like this one, and then x-axis. What does this x-axis represent in this case? All the values in the data set, exactly. They represent all the values. You could have 1, you could have 10, you could have 100. Doesn't matter. The x-axis represents all the values, possible values in the data set. What does the y-axis represent? The frequency of each value in the data set. The taller the vertical line is, the more frequency of that value in that data set. So if you know the frequency, if you know the value, can you estimate the probability of that value appeared in your data set? Can you? Yes, you can look at the vertical line. If you want to see a range of a probability, the probability of a range of a value appearing in the data set, that will be where? That will be the area under the bell shape. All good? All good? If the vertical line represents the frequency of that value appeared in your data set, of course, the area under the bell shape represents the probability of a range of a value in the data set. Remember this bell shape, symmetric bell shape, very, very important. I cannot emphasize enough. Very, very important. The reason we need to remember this symmetric bell shape is that we need to talk about central limit theorem in the future, which is the foundation of multiple important statistical models. Remember that. Later, I will talk about central limit theorem, right? Of course. But at this moment, I want you to keep remembering the bell shape, symmetric bell shape. This is called a normal distribution. The other two, it's fine if you ignore them at this moment. Just remember that, you see, the other two is twisted a little bit, right? It's not symmetric. So we call the one on the left skewed a little bit. It's not symmetric anymore. Or negatively skewed. No matter left skewed or negatively skewed, you remember that the mean is to the left side of the median or the mode. If you have a distribution like this one, it's called a left skewed or negatively skewed. On the right, you have an example of right skewed and positively skewed. Of course, the mean value is to the right of the median or the mode. Just remember how they are called. But the most important one is normal distribution, symmetric distribution. All good about this? Okay. If all good, we'll talk about. This is how you calculate. When you are given a data set, you calculate the symmetric coefficient. Just remember where you can find this equation. You are not to remember the equation itself, right? Another way to measure the shape of a data set is called curtices. We have three types of curtices: elliptokurtic, mesokurtic, platykurtic. Right. Ellipto means your data set tend to be slender. Ellipto. meaning that you have the central value, no matter mean, mode, median, doesn't matter. You have the central value, and then the rest of the data set varies closely to the central value. That's why you have a slender shape. Then we have platykurtic. Platykurtic means your data set spread out, tend to spread out. You have a mean value, and then you have a data set spread out of you around the central value. That's called a platykurtic. Different shapes, right? Remember how they are called. Also, I have some equations for you to calculate. You are not required to remember the equation itself, but just remember that where you can find this equation if you need to use it. Next, I want to talk about covariance and correlation. We just talk about the centrality and dispersion of one data set, right? Just one data set. But what if you want to measure the changes between two data sets? What factors should we use? We use covariance or correlation. Correlation is more frequently used than covariance. This is how you calculate covariance, right? Basically, the numerator will change to the sum of a product. You use each data set to calculate a difference, right? Then you multiply these two differences, add them up, add the product up, divided by, if you calculate the population covariance, divided by n. If you calculate sample covariance, divided by n minus 1. This is how we calculate covariance. Correlation, basically you use covariance to divide the product of the covariance. This is how you calculate correlation. Remember, correlation can only be any value between -1 and 1. Any value between -1 and 1. If you have a correlation value 1, what does this mean? That means if you change one data set, right, the other data set will change completely towards the same direction. If you have 0, that means if you change one data set, the other data set does not change. -1, if you change, let's say you change data set A positively, the other data set will change negatively. Yes. This is how you show the relationship between two data sets. Use correlation. Next, let's talk about how we process outliers. We just talk about empty cells, right? We have different strategies. Outliers are some extreme values in the data set. They don't appear in the data set very frequently, but if you have outliers, it can twist the data set. It can significantly influence the data set. How can we process outliers? First, you need to detect outliers. We use this method. We just talk about IQR, right? Interquartile range. Interquartile range shows you 50% of your data set could vary in the range in IQR. If you want to see if a data set a data value is an outlier, is an extreme value of the data set, first, you need to calculate IQR. Then, as a convention, we multiply IQR by 1.5. 1.5. This is just a convention, right? 1.5. And then from your first quartile and the third quartile value, from the third quartile value, you want to minus 1.5 times IQR. From the third quartile value, you want to plus 1.5 times IQR value. If a data value is outside of this range, we consider it as an outlier of the data set. It's just a convention, right? Because we have multiple different ways of evaluating whether a data value is an outlier. So we have to find a standard way. That's why we use 1.5 to multiply IQR to calculate a range of values. If a data value is outside of this range, we consider this value an outlier. Are we all good about this? If all good, I want to stop here.